Okay, we have here a question that's going to involve stoichiometry and the limiting reagent. So it combines two skill sets. The question regards the reaction of ammonia with oxygen to form mononitrogen monoxide and water. We're told that we start off with 3 grams of ammonia and 5.5 grams of oxygen. So it looks at first glance as though there's an excess of oxygen. But we find out that because of the stoichiometry, which is 4 to 5, and again I stress that you need to have a balanced equation before you start doing a calculation of this nature. If you're not using a balanced equation, then you're going to make a nonsense calculation. It's got to be a balanced equation before you start anything. So the first step in doing this is to find out how many moles of both of the reactants that we have. 3 grams divided by the molar mass of ammonia, comprised of the molar mass of nitrogen and 3 times the molar mass of hydrogen, gives you that many moles of ammonia, 0.176, and a bunch of other numbers. I've retained all the numbers in the calculation. You only round off at the end when you have to report the value. Never round off during the calculation or you'll introduce rounding error. We have 5.5 grams of oxygen divided by the molar mass of oxygen. Keep in mind that oxygen is diatomic. So we have 0.17188 moles of oxygen. And then what I did in the next step of the calculation to find out which one of these two is limiting, they appear to be almost the same amount of quantities when it comes to moles, but we have to factor in the stoichiometry, which is 4 to 5. How do I know how to write the stoichiometry of the reaction? I put 5 moles on the bottom because I'm trying to get rid of moles of oxygen. I could have started the calculation here, by the way, but I decided to use oxygen as my starting point. Either way, we can find out which one is limiting. So the stoichiometry is 4 moles of ammonia used for every 5 moles of oxygen used. That allows us to cross off moles of oxygen, and we find out that it takes 0.137 moles of ammonia to react with this quantity of oxygen. So it takes this many moles of ammonia, but we have this amount. Given that this number is smaller than that number, it tells us we have an excess of ammonia. If we have an excess of ammonia, it means that the limiting reagent is the other one. So oxygen is the limiting reagent. So I put that in words here. Since 0.137 moles of ammonia are needed and 0.176 moles of ammonia is available, it tells us that ammonia is in excess, therefore O2 is limiting. In the next part of the question, we're asked to solve how much of these two substances are produced. So I began with, having found out that oxygen is the limiting reagent, I start the calculation with the number of moles of oxygen, and I put in the stoichiometry from oxygen to mononitrogen monoxide. I find out that I need that it generates 0.137 moles of nitrogen monoxide. Multiplied by the molar mass of nitrogen monoxide gives me that many grams. Obviously, I'm not going to report it to that level of accuracy. I'm only allowed 3 sig figs, so 4.13 grams of nitrogen monoxide is produced. In the next step, I again begin with the moles of oxygen that are available. I multiply by the stoichiometry from oxygen to water, again putting oxygen in the bottom because I want to cancel oxygen. 6 moles of H2O is produced for every 5 moles of O2 used. That means we produce 0.206 moles of water, multiply by the molar mass of water to get grams of water, and then finally report it to the correct number of significant figures. So 3.72 grams of water is produced under these conditions. In the last step, I've subtracted this number from that number. Why? Because that's how much ammonia is going to be used by the reaction before this is finished. Once this is finished, the reaction stops, and I'm going to have some ammonia left over. So this number, the original amount of ammonia, minus this number, the amount of ammonia that was used by the reaction, is going to tell us how much ammonia is left over. So I've subtracted the smaller from the larger. That many moles of ammonia is left. I multiply that by the molar mass of ammonia to get grams of ammonia, and finally I report it to 3 significant figures, 0.658 grams of ammonia. In the last step of the question, we're asked whether the conservation of mass is respected. So conservation of mass tells us that the amount of matter going in from one side of the equation has to equal the amount of matter coming out on the other side of the equation. So mass in has to equal mass out. So the sum total of the reactants should equal the sum total of the products. Remember, not all the ammonia is used up, so even though it counts as a reactant, because it's not used up, it comes out on the, after the reaction, we can also count it as a product, as it were. Otherwise, we'd be counting it twice on the left side. So these numbers added together should equal these two numbers added together, and sure enough, they do. Well, we got a slight inaccuracy, but that was due to rounding. It's not an error. So 8.5 equals 8.5, meaning amount of matter in equals the amount of matter out. So the law of conservation of mass is respected, and that tells us we've correctly done the calculation.